Hey, my dear friends, I'm your guestess. So, today I'm explaining you guys what is force and types of forces. Also, what is pressure and types of pressure, and what is SI unit of them. Okay, what are the characteristics, and we'll also go into more advanced topics and learn it and enjoy the chapter. The first thing, let's discuss about force. The first half of the chapter is about force. Now, when you talk about force, there are many instances which shows that a force is there. Now, what is a force is a question. Force is something which you push or a pull, an object, not something like a push or a pull, which is exerted on an object is called a force. Getting my point? Push or a pull on an object is called force. Now, footballer kicked the ball. Now, what is this? He's using some force to kick it. Getting the point? Footballer kicked the ball. What is he? He's using some force. Similarly, there are many activities which require force so that it can be completed. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, and pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change in the motion of an object. Can these terms be replaced with one or more terms? Let us find out. Do you know? Okay, yeah, there's a table over here, and it has, I guess this is about the actions. What actions do you think can happen? Now, opening or shutting a door, of course, pushing or pulling. Okay, pushing or pulling. What could be there? What could be there? If people, yeah, shutting is also correct. Shutting is also one thing correct. Here, even kicking people, few people just kick and come. But still, main things are pushing, pulling, and shutting, what I feel. Now, drawing a bucket of water from well, that is, you're pulling. Okay, you're pulling or you're lifting it with the rope or you're picking it up. So, okay, something like that. And a football player taking a penalty kick, of course, your kicking would come in this particular thing or hitting the ball or something like that. And yeah, in cricket ball at that time, cricket you use hitting, but in football you use kicking. And moving a loaded cart, we have to push. Okay, push. Yeah, opening a drawer also pull. And yeah, these are few activities, and whatever activities which I might have missed or which I might have didn't think that much, just tell me those activities and message in the comment section so that I can once see that and I can also learn something from you. Now, in science, a push or a pull on an object is called a force. Now, from last in this introduction part, the central meaning or central definition, the main topic is force and what is force. What is force means a push or a pull on an object. Now, forces are due to an interaction. Okay, forces are due to an interaction. There is an interaction between an agent and an object. When both are in some interaction, forces are exerted at that point of time. Okay, now you can see a car being pushed by man. If the man doesn't push it, of course, how can we see a force there? Okay, might be different other kind of forces are there, but there is some interaction which is causing a force over there. Okay, now here we have who is pushing who. Now these both are pushing, these both are pushing themselves. Now here, can we say that let me just assume that this girl is Gina and this girl is Meena. Now let me assume that Meena is exerting more force. It isn't like that, because at both the sides there's an equal force. Okay, so yeah, and the person or the particular person who exerts more force will win or will push the other one. You're getting the point? And now let's explore forces. Now there is an activity over here, like now you can see A and B picture here, figure. Let me explain you guys about this. The first one, here two people are pushing this box, this cart. Now, of course, this cart will move front. Reason is these both are involved. Now, when these both are pushing, the net force which is there, it is added. Okay, when the both are pushing, okay, when the both are pushing the box in opposite directions with equal magnitude, that time, there is a difference between the first and the second force. If this is 10 newton, if this is 5 newton, there's a 5 newton difference. If it's a 10 newton and 5 newton, both are at the same side, then it's 15 newton is the sum here. We're talking about sum here. Now sometimes uh, the strength of the force is usually expressed in magnitude. Okay, and the SI unit of force is newton. You have to just remember this. Now, force can change the state of motion. For example, while taking a penalty kick in football, the player applies a force on the ball before being hit. The ball was at rest and so its speed was zero. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps to save the goal. By action, the goalkeeper tries to apply a force on moving ball. Now, when the ball is moved, what is being changed here? The state of motion of the particular object, and the particular object here is a ball. Okay, now it is changed. That's, this is some example which states you about that particular change. Now, force not only changes the state of motion, rather it changes many things. You can see over here, it can change, a state of the motion. That is something which we learned. One more thing is that it can change the speed of the object. If it is moving, it can change the direction of it, it can change the shape or size of it, or it can make the object which is moving into rest position. So yeah, force can make certain changes on the objects. Now there are two types of forces: contact forces and non-contact forces. In contact forces, agents and the object are in contact, and when a force is resulted in the contact between and object, that is called as a contact force. Now you can have examples like muscular force, in that even frictional force. The muscular force is the force which is resulted due to the action of muscles. Okay, and it is a type of a contact force. And frictional force is something which we are learning new. Muscular force means we're getting from the name of it, that muscles. Okay, something like that. But for the frictional force, the main central topic is that it opposes the direction of a state of motion of an object. Okay, it opposes the direction, of a motion. It opposes the direction of a motion. So, this is the main property of friction, and more about friction you learn in the 12th chapter, which is the next chapter. And in non-contact forces here, by the name we understand that the force which is resulted, even if the agent and the object is not in contact with each other. The magnetic forces, we know that the unlike poles attract each other, like poles repel each other. This attraction and repulsion, what are these? These are somewhat an example of push or pull. There's some kind of, what do you say that? A force exerted. Now, what is this? It's a magnetic force. Magnetic force is a type of a non-contact force. Similarly, with electrostatic force, the force exerted by charged body on another charged body or uncharged body is known as electrostatic force. The principle is same here again. And about electric charges, you'll mostly learn in chapter 15, natural phenomenon. Okay, in gravitational force, now this is a force, many people, I guess, like wherever we hear gravity, we have a film on gravity. But like, what is gravity now? It is something, it is something which brings the object downwards. Okay, objects or things fall towards the earth, fall downwards. Okay, downwards in the sense towards the earth, because it is pulled by some force called gravitational force, or force of gravity, or just gravity. Okay, yes. Now we're done with force. Now let's get back to pressure. Okay, now here pressure doesn't mean pressure, or that pressure which pressures, if you do some work, I will have that pressure, not that pressure. But somewhat similar kind of thing, definition only. Now, the force acting on a unit area of a surface is called pressure. Okay. Now you put a lot of pressure, to do some work. Okay. Now to carry heavy load, of course, we keep a lot of pressure. To carry somewhat like a small, what do you say, small specs, it's not a heavy load, so we don't, it's just less pressure what we are using to carry it. But when we talk about more, like bags, okay, 2 3 bags, catching those 2 3 bags, it's, we need a lot of pressure to be exerted so that it is easy for us to carry. But yes, now let's get into this topic and let's learn how is pressure exerted by liquids and gases, what is atmospheric pressure, and we'll also learn the last topic. It's a suspense. Yes, without wasting any time, now let's just get into this pressure topic. Now let's, when we talk about pressure, we have to know one principle. Smaller the area, larger the pressure. Okay, smaller the area, larger the pressure is. Greater the area, okay, larger the area, smaller the pressure is. If you understand this principle, you can just, you not acing, you can just be a pro in this topic. The pressure is also exerted by liquids and gases. How? How is a question now? Let's, I'm just, now for example, let's take a container over here. In this container, after like filling the bottle, particular bottle fully, now what we'll do is let's just keep few holes. Okay, now we could see that suddenly, suddenly the liquid exerts pressure on the walls of the container and the water comes out. Okay, and where it comes fast, that is a different aspect here. But according to the activity, pressure, uh, you know, it is, when we talk about the liquids, it exerts on the walls of the container. The pressure exerted by water at the bottom of the container depends on the height of its column. This is a main thing, it depends upon the height of this column. Okay, depending upon it, pressure is exerted by water, in this bottom part of the container. You're getting? Now, gases to exert pressure on the walls of the container similarly like liquids. Okay, now when we talk about atmospheric pressure, pressure exerted by air is known as atmospheric pressure. This is something which we're learning from lower grades, but we have more topics like, now let's just let's just get back to the main suspense topic which I was talking about. Yeah. 1 minute, 1 minute. Yes. So actually, and when we talk about atmospheric pressure, there is an experiment. Okay. According to this experiment, like why, there would be a question, why don't we get crushed under this weight? Okay. In the atmosphere. Why don't we get crushed? Reason is, the pressure inside our body, the whatever pressure is in internal part of our body, pressure in internal part of our body is equal, okay, is equal to the atmospheric pressure, and it cancels the pressure from outside. Okay, the internal body pressure and atmospheric pressure are equal, and it cancels the pressure from outside. Okay, you getting this? I hope you understood this chapter. It's a really good chapter. It involves many points, scientific points, which we have to keep it in our mind so that we can ace physics. Physics is really good. In the next chapter, of course, in friction, we'll learn more things, and after that, we even have sound and many more lessons to come. Let me not reveal all those lessons presently, but tata, bye bye, and meet you in the next video.